and welcome to MathSux. This video is going to help you pass the Geometry Common Core Regents. We're doing this one question at a time. Here is question 1. On the set of axes below triangle A, B prime, C prime, so if we look at this, we have A, B prime, C prime, is the image of triangle ABC. So this is the image of the smaller triangle, triangle ABC. What is the scale factor and center of dilation that maps triangle ABC onto triangle A, B prime, C prime? So notice we're going to be finding the scale factor and the center of dilation. So the scale factor and the center of dilation. So if you notice point A, notice that point A is in both triangles, and because they're in both triangles and it remains unchanged, that's actually going to be our point of dilation, our center of dilation. So point A, or vertex A. So already we can eliminate choices 1 and 2 because this is not centered at the origin. It's centered at point A since it's unchanged. So since we know that, we can look at one of the other points before and after the dilation and with respect to point A. So if we look at point B, we're not looking at this in relation to the origin, but in relation to point A. So we're kind of pretending this is like our new temporary origin. So if we look at point B in relation to point A, this coordinate would be, so it's kind of like we're drawing a new coordinate plane right along here. So this is like our new 0, 0. So B with respect to this point A is going to be 0 and then up to. Just treating that like it's like a normal coordinate plane. So this is 0 and up to. And then B prime with the same idea, using this as like our new origin temporarily. Let's see what this becomes. This is going to be B prime 0, 1, 2, 3, 4. So this B 0, 2, the B prime with relation to the center of dilation at A becomes 0, 4. So you could see that we're doubling the points from 0, 2 to 0, 4. So we know that our dilation is going to be 2. So it's 2 times the dilation, which is choice 4. Question number 2. Line segment PAQ has endpoints whose coordinates are P -2, 6 and Q 3 4. What are the coordinates of point A such that PA to AQ is 2 to 3? So here, these questions always come up on all of these tests, and there's a nice formula for this. So I'm just going to write it out. So there's going to be a formula for the x coordinate and a formula for the y coordinate. So here's the formula for the x coordinate. We have x1 plus a over a plus b times x2 minus x1. So if you're wondering like where did all these points come from, they just come from right here. So we could label this x1, y1, this p, q can be x2. Let me actually write them over here. So we have p is -2, 6, which we'll call x1, y1, q is 3, 4, which we'll call x2, y2, and then a to b is going to be that ratio. So now we can fill in this formula. So we have x is equal to x1, which is -2, plus a, 2, over a plus b, 2 plus 3, times x2, which is 3 minus x1. So minus -2 will give us plus 2. And then we could just figure this out. So we have, this will become 5 times 2 is 10 over 5, which is 2. So then this is going to be equal to 0. So we have x is equal to 0. So already we could just see that the only x value equal to 0 here is choice number 4. So we know that's going to be our answer. But let's also do the y value for this. So we could see that it'll be equal to 2. So we have y is equal to y1 plus a over a plus b times y2 minus y1. And then we're just filling in that formula again. So we have y1 is 6 plus 2 over 2 plus 3 times -4 minus 6. And this all works out to y is equal to 2. So we get the coordinate point 0, 2, which is choice 4. Question number 3. On the set of axes below, congruent parallelograms ABCD and RSTU are graphed. Which sequence of transformations maps ABCD onto RSTU? So we're going from ABCD to RSTU, so we're going this way. So let's just go through each answer choice and see what makes sense. So this first one says a reflection over the x-axis followed by a translation 10 units to the left and 1 unit up. So to see this, I'm going to pick 2 points that are going to match up with each other. So you could see that A and R. So I'm going to be focusing on these 2. So first it says a reflection over the x-axis. So if we reflected A over the x-axis, let's see what we would get. So this is 1, 2, 3, 4 units away. So now it's going to be 4 units away the other way. 1, 2, 3, 4. Okay, so reflection over the x-axis followed by a translation 10 units to the left. So if we went 10 units to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You could see that we're not going to be lining up with R. So let's try the next one. A translation 4 units down. So 1, 2, 3, 4, followed by a reflection over the y-axis. 1, 2. So you can see that this works out. So choice 2 is going to be your answer. And if you look through these other answer choices 3 and 4, you could see these wouldn't work out. I also have a whole playlist on transformations that goes over everything. So please check that out. Question number 4. Triangle ABC has a right angle at C. So let me just start by drawing this out so we can get a picture of it. So it's a right triangle at C. So we could just fill in AB. The legs don't matter really. So don't worry too much as long as you have that right angle at C. And then it says if AC is 7.7 and angle B is 24 degrees. It's over here. What is AB to the nearest tenth? So we're trying to find the hypotenuse, and with relation to this angle we have the value of the opposite. So here we're going to be using SOHCAHTOA. So notice we have this labeled, so we have the hypotenuse and the opposite. So we're going to be using sine. So we have sine of 24 degrees is equal to the opposite, 7.7, over the hypotenuse, x. And now we just need to solve this. So we could do some cross multiplying. And we could plug it in our calculator now. And we get x is equal to 18.9 degrees. They wanted it to the nearest tenth. And this is choice number 1. Question number 5. Given triangle PQR and triangle LMN with PQ is congruent to LM, which additional statement is sufficient to always prove triangle PQR is congruent to LMN? So let me draw this out. You can at least try to visualize what they're telling us. So we're going to be trying to prove 2 triangles congruent. And they don't give us a lot of information. So we have PQR. So just make sure that they're in the same order. So that's like the key to this kind of a question when they don't give you pictures. So we have PQR, and then we want to keep the same order for LMN. So we want LMN. So we did PQR, LMN. And it says PQ is congruent to LM. Which additional statement is sufficient to always prove triangle PQR is congruent to LMN? So notice, looking at these answer choices, they all have this piece, QR is congruent to MN. So you could just add that into our proof here. QR is congruent to MN because they all have that. So now we know we have 2 sides. So to make this missing piece, we know that we're going to need a side angle side. So that's what we're going to be looking for, because that's one way to prove triangles congruent, and that's kind of like the missing piece we have when we look at these 2 triangles. So we know we're going to be looking for something that has angle Q congruent to angle M. That's like the missing piece. And that is shown here at choice number 2. So choice number 2 is our answer. So just be aware of all the different ways you can prove triangles congruent, and that's what's going to help you with answering this question. And try to draw out a little picture for yourself so you can look for those. Question number 6. The equation of a circle is x squared plus 6y equals 4x minus y squared plus 12. What are the coordinates of the center and the length of the radius? So here we're going to be completing the square 2 times to find the center and the radius. So the first thing I'm going to do is just bring this equation down. And I'm going to want to get everything to one side and close and near each other. So I'm going to want to bring the x to the other side and make sure that it's near that x squared. So x squared minus 4x plus 6y, and then I'm going to want to bring the y squared over also. So this will be 6y plus y squared, and then that 12 I'm just going to leave there. So we're going to be completing the square 2 times, once with the x values and once with the y values. So to do that, I'm going to divide this minus 4x divided by 2, and then we get minus 2, and then I'm going to square it, and we get 4. And then I'm going to do the same thing over here, plus y squared. I'm just going to put that y squared first, plus 6y, and then I'm going to do the same thing. 6y divided by 2 is equal to 3 squared equals 9. So I'm going to add that 9 here. So I'm going a little fast, but if you want to see a slower example of completing the square, please check that out, because there's so many little steps that seem like they don't make any sense. So it's definitely something important to practice. And now on the right side of the equal sign we have 12, and then everything I boxed off here that we kind of like made up that almost didn't make any sense, that's what we're going to add on the other side as well. Because we added it to one side, we're going to add it to the other side. So plus 4 and plus 9. Okay, so now what I'm going to do is rewrite each part of this. So we're going to rewrite this x, and then this number that we got when we divided by 2, negative 4 divided by 2, we got negative 2. That's what we're going to put here. So x minus 2 squared plus, and then we're going to do the same thing with y. So y, when we divided 6 divided by 2, we got 3, so this is going to be y plus 3 squared. And then we're just going to add everything over here on the right, which gives us 25. So now we can, from this, find our center and radius, where we're just going to take the opposite positive and negative values. So this is minus 2, so the x value here is going to be positive 2, and then y is going to be negative 3. So we have 2, negative 3, and then the radius is always going to be the square root of the number that's to the right of the equal sign. So that's square root of 25, which is equal to 5. So our answer here is 2, negative 3 with a radius of 5, which is choice number 1. Question number 7. A square with a side length of 3 is continuously rotated about one of its sides. The resulting three-dimensional object is what? So here we have a square with a side length of 3, where it's equal all around because it's a square, and then we're continuously rotating it about one of its sides. So if you just imagine we're flipping this all around, it would look something like this. And you can see that this is going to form a cylinder. So I'm just going to redraw this now as a cylinder with a height of 3. So notice they're saying the result is a cube or a cylinder, so obviously this is not a cube, so choices 1 or 2 we could get rid of, but it's also asking for the volume. So the volume of a cylinder is equal to pi r squared h. So this is going to be equal to pi times the radius here is also going to be 3, right? Because we rotated this square on one of its sides, that means that this entire length is 6. So this is going to be 3 squared times 3, which is going to give us 27 pi, which is choice number 3. So really, so I kind of didn't draw this right. So we got the shape right, but if you're thinking about the length of the radius, this square is being continuously rotated about one of its sides. So if we chose this side to continuously rotate it, that means we're going to be going this way and rotating it this way. So there'd be another square over here, and that's why half this radius of this cylinder is going to be equal to 3, because we're kind of like doubling up our squares to make this cylinder, so it goes all the way around. So choice number 3 is our answer. Question number 8. Line K is represented by the equation 4y plus 3 equals 7x. Which equation represents a line that is perpendicular to line K and passes through the point -5, 2? So if we're looking for something perpendicular, we're going to be needing the negative reciprocal of the slope of this. So let's first find the slope. So we have 4y plus 3 equals 7x, and we just want to get that y alone. That the slope of this original equation is equal to 7/4. So what we're going to want in our new equation is to have the negative reciprocal of that, which is when we flip and negate it. So we're going to flip the numerator and denominator to get 4/7 and negate it. So this is going to be our new slope. So already looking at these, you could see numbers 1 and 2 don't have a negative reciprocal. So now the next piece of information they give us is the point. When we plug this into point slope form, we're going to get y. So this is x and y, so we're going y minus 2 is equal to the slope -4/7 times x minus x1, which will be plus 5. So this is our answer, which is choice number 4. Just a reminder about point slope form. There's a formula for that, so that's y minus y1 is equal to the slope, represented by m, times x minus x1. So that's point slope form, and that's all we did. We just found the slope and then plugged in the points that they gave us for x and y. Question number 9. Scaling triangle JKL is drawn below. If median LM, so we're drawing a median, LM is drawn to side KJ, which statement is always true? So I'm just going to draw this in. So the median of a triangle is a line segment that comes from the vertex, in this case point L, to the midpoint of the opposite side. So we know that the median is going to split line KJ into equal parts. So we're looking for something that says KM is congruent to MJ. So if you look at this, you see that there isn't something exactly that says that. So this question could be a little confusing at first. So let's look at each one and go through what makes sense. So the first choice, LM is equal to KM. So that doesn't make sense. LM is equal to KM. No. Number 2, KM is half of KJ. So this is confusing, but this is actually going to be your answer, because if you look at what this is saying, KM is equal to half of this whole segment KJ, and that's another way of saying that KM is equal to MJ, because they're equal parts, because half of KJ will be equal to KM and it'll be equal to MJ. So it's confusing, but that is our answer. Yeah, the important part here is to know that this is what a median of a triangle is. It's splitting KM and MJ into equal parts, and then just being really careful here about what makes sense, because none of these other choices make sense either, which is another clue. This is talking about angles, perpendicular, which is not the case, and then this also is talking about angles, which is not the case with a median. So choice number 2 is our answer. Question number 10. In circle O, chord KA intersects diameter YN at S. If YK, so we're over here, is equal to 120 degrees, and YA over here is 105 degrees, what is angle ASN? So we're looking for this angle here. So the first thing I want to do is find this value of AN. And because this is a diameter, we know that this entire half of the circle is going to have to add to 180. So to find this, we're going to do 180 minus 105, which gives us 75 degrees. So we know that arc AN is equal to 75 degrees. And we want to find this angle. And to do that, we're going to be doing a formula for intersecting chords. So the angles formed by intersecting chords. So even though this isn't a chord, this is a diameter, it's going to be treated the same using that same formula. So just to, so I'm going to just label this x degrees. So we're finding x degrees equal to, this is the formula, 1/2 times, and then you see these arc that it's intercepting the arc AN, and then plus the other arc on its other side, the vertically, KY, so arc KY. So 1/2 of arc AN, which is 75 degrees, plus arc KY is 120 degrees. And then this is going to come out to 97.5 degrees, which is choice number 3. Question 11. Triangle ABC is graphed on the set of axes below. The vertices of triangle ABC have the following coordinates. A is -3, 4, B is -5, -1, and C is 3, -2. What is the area of triangle ABC? So there's different ways of doing this. I'm going to do this where we map out a rectangle around this triangle, or triangle ABC, and then find the area of the rectangle. So let's first do that. Let's form a rectangle. So the area of this rectangle is just going to be the number of units length times the width. So we have 1, 2, 3, 4, 5, 6, 7, 8 times 1, 2, 3, 4, 5, 6, which gives us 48. And notice, so we're finding the area of the rectangle, and then notice we have all these 3 right triangles that we formed with our rectangle. Triangle 1, triangle 2 this way, and then this little triangle, triangle 3 down here. So if we find the areas of each of these triangles and then subtract it from the total rectangle, we'll be left with triangle ABC. So let's find the area of triangle 1, which is going to be 1/2 times the base times the height. So you could see, and here we could just count units. So the base is 2 times the height, 1, 2, 3, 4, 5, which will just give us 5. Area of triangle 2, 1/2 times the base times the height. And then the area of our last triangle, triangle 3. And now we can take the area of a rectangle and then subtract all the areas of these triangles that we just found. And we'll get 21, which is choice number 3. So this is the area of this triangle ABC. Question number 12. In triangle ABC below, DE is a mid-segment and BD is congruent to DE. So let's look at this. DE is a mid-segment. So that tells us a couple of things. DE is a mid-segment of this triangle. So that means that this is going to be congruent to this over here. BD is going to be congruent to DA, and that also BE is congruent to EC. It's also going to tell us that these lines are going to be in proportion. So this, let's say, has a value of x, and then this is going to be 2x. So this is always going to be twice the value of the mid-segment. Another thing it tells us is BD is congruent to DE. So BD over here is congruent to DE. So if we look at this, we could see that there's 2 triangles. There's a little triangle, triangle BDE, right? This looks like it's an isosceles triangle. right? Because these two sides are congruent. And then we also have this bigger triangle, triangle BAC. So this was x and this is 2x. Another thing is these two triangles, they're going to be similar to each other by angle, right? They share this angle B. And then this is, whenever we have a mid-segment, it's always parallel to the base. So we know that these angles are going to be congruent to each other as well. Angle D and angle A. So by angle, these two triangles are similar to each other. And they're also in proportion, right? So that means their sides are in proportion. So this is x, this is 2x. And because this is isosceles, the smaller triangle, which they gave us, that means this bigger triangle is also going to be isosceles. So looking at these statements here, the first one says triangle ABC is isosceles, and that's actually going to be our answer, triangle. So that's a big triangle ABC. They're both isosceles. And if you look at the other choices, they don't make any sense. Triangle ABC is scaling, no. BD is congruent to BE, no. It gave us that it's isosceles BD to DE, so that doesn't make any sense. And then the last choice, DA, is congruent to EC, no. So it's a mid-segment cutting BA in half and BC in half, but not, these segments are not equal to each other. So choice 1 is our answer. Question 13. As shown in the diagram below, JKL is parallel to MNOP. So JKL is parallel to MNOP. OR is congruent to ON. So OR over here is congruent to ON over here. So this is an isosceles triangle. Okay, so now let's look at our more information down here. Angle POR, so over here is equal to 116 degrees. What is angle LKN? LKN. So we're trying to find this value over here, and we're given this. So the first thing I'm going to want to do is, so since they said this is a line, MNOP, we know that this whole thing is going to add to 180. So I'm just going to do 180 minus 116, and when we do that, we'll get 64 degrees. So this right here is 64 degrees. And because these two sides are equal, and this is an isosceles triangle, we know that these angles are also going to be equal to each other. So the whole thing is going to have to add up to 180 degrees. So when we do that, we'll get 58 degrees. So each of these in here is 58 degrees. Okay, now we're almost there. So again, we have this whole line, MNOP, and we know that this is going to have to add to 180. So the other side of this angle would be 180 minus 58, which is equal to 122. So in here is 122. And this is where the idea of transversals are going to come in. So whatever values over here, based on alternate interior angles, is also going to be over here. So this over here, this angle we were looking for is x is going to be 122 degrees for angle LKN. LKN. Yeah, so this is choice number 3, 122 degrees, based on alternate interior angles. Question 14. The ratio of similarity of square ABCD to square WXYZ is 2 to 5. If AB is equal to x plus 3 and WX is equal to 3x plus 5, then the perimeter of ABCD is what? So let's draw out some squares here. So they're similar. So if so let's say this is square ABCD, and it says AB, so over here is equal to x plus 3. And then a similar square, WXYZ, so let's make it bigger, where WX is equal to 3x plus 5. And they're saying the ratio of similarity is 2 to 5. So what we can do with that is say that 5 times the first square is going to be equal to 2 times the bigger square. 5 times this first little square is going to be equal to 2 times this big square as just the ratio. That's all this represents. And setting this up will allow us to find x and ultimately find the perimeter. So let's just distribute like normal. So we get x equals 5, but that's not what they're asking for here. They want to know the perimeter of ABCD. So if we plug in 5 for x, we'll see that each side of ABCD is equal to 8. So all we have to do for the perimeter is add 8 4 times for each side of the square, and we get 32, which is choice number 3. Yes, this could be a little confusing because you have to think about this ratio and what it means. So 5 times the little square is going to be equal to 2 times the bigger one. Question 15. In parallelogram ABCD below, diagonals AC and BD intersect at E. Which transformation would map triangle ABC onto triangle CDA? So we're trying to map triangle ABC onto CDA. Right, so we're trying to go like that way. Okay, so let's first look at this first answer choice, a reflection over AC. So I think this is kind of a hard question because it's hard to envision this. But if we look at this little sample here I made, if we folded this in half over AC, notice this is not going to work out. This is not going to map triangle ABC onto triangle ADC. It's going to be missing the point. So this is actually not our answer, even though it might seem that way. So let's look at the next choice, reflection over DB. So we know that's not going to work out because we're trying to map on triangle ABC to triangle ADC. So if we map over DB, that's along this way. So those are the wrong triangles, so that's not our answer. A clockwise rotation of 90 degrees about point E. So if we just flipped triangle ABC, so let me cut this in half. So we're just moving triangle ABC. So we have our triangle ABC and we're trying to map it onto this triangle. What we end up doing is, if it's a clockwise rotation of 90 degrees, we're going to end up doing something like this, right? Because we're only moving at 90 degrees. So that's not our answer. So by process of elimination, it has to be choice number 4. But let's look at why. So if we're doing a clockwise rotation of 180 degrees about point E, right? So that's an important thing. It's centered at point E. It would look something like this. So here was 90 degrees and now we're turning it another 90 degrees and we're mapping it onto the other triangle. So choice number 4 is our answer. This is hard because it's hard to visualize. If you can, maybe use the scrap paper on the test and make yourself a little parallelogram to test it out. Question 16. The square pyramid drawn below has a volume of 175. If the height of the pyramid is 21, what is the perimeter of the base? So they mentioned this is a square pyramid, so we know it's going to be equal on all sides of that square base. So let's look at what the volume of a pyramid is. So it's the volume of a square base pyramid is 1/3 b squared h. And in this case, they gave us the volume, which is 175. So we're setting this equal to 1/3, and then we don't know what the base height is, right? So base squared, we're going to leave that as b squared times the height, which they gave us, which is 21. And now we're just going to use algebra to figure this out. So we get b squared is equal to 25. Take the square root of both sides and we get b equals 5. So before we circle 5, be careful because remember they wanted the perimeter of the base. So the perimeter is just when we add up all the sides together. So if we're adding up 5 plus 5 plus 5, right, because each of these is 5 because it's a square base, we're going to get 20, which is choice number 3. Question 17. A glass fish tank is designed to be placed on a stand in the corner of a room with perpendicular walls. The tank can be modeled using part of a cylinder as shown below. The inner length of the fish tank along the wall is 22 inches and the height of the tank is 27 inches. How much water to the nearest gallon does this fish tank hold? So this can sound a little strange and a little hard to picture, even based with the diagram here. So if we have, this is a cylinder, but it's standing in the corner, so it's kind of like a quarter of a cylinder. So knowing that, we're going to be finding the volume of a cylinder, but we're going to be dividing it by 4. So the volume of a cylinder is pi r squared h. We're going to be dividing it by 4 because it's in a corner. So like the top view, like if you have the top view of a cylinder, it would look like a circle, but we're only doing the corner of our room, which is like a quarter, like that. It's like a little piece of the pie. So that's the top view of what's going on here, and that's why we're dividing it by 4. So now we can fill this in. They give us all the information we need. R squared, we could see the radius is 22 squared times the height is 27. And then don't forget, we want to divide this all by 4. So the normal volume formula of a cylinder and then divided by 4 because we're getting just that quarter of this. So we have 22 squared times 27 times pi, and then all divided by 4, and we end up with this number here. So just taking a glance at the answer choices, you can see there's nothing that looks like this, right? If you go back to what they're really asking, they wanted this to the nearest gallon. So we have inches cubed, but they give us this conversion right here. So we're just going to divide by 231 because that's how many inches cubed are in 1 gallon. So we divide this by 231 and we end up with 44.4, but we're going to just round to 44 to the nearest gallon, which is choice number 1. Question 18. Line M, whose equation is y equals negative 2x plus 8, is dilated by a scale factor of 1/2 centered at the origin. Which equation represents the image of line M? So when we're dilating a whole line, there's 2 things that can happen. The line can remain completely unchanged, or we're just dilating the y-intercept. And the way you know which one to do is by graphing the line. So let's graph the line. We have on our calculator y equals minus 2x plus 8. And then we need to see if the center of dilation, which in this case is the origin, is a point on this line. So let's scroll down and see. Okay, so point of the origin 0, 0 is not a point on this line, right? It doesn't go through the origin. Therefore, we can use the scale factor of 1/2 to adjust the y-intercept. So our slope is going to stay the same. And then we're just going to apply the scale factor of 1/2 to 8, which will give us 4, right? 8 times 1/2 is 4. So we get y equals negative 2x plus 4, which is choice number 2. Question 19. In right triangle RST below, altitude SV is drawn to hypotenuse RT. So whenever we're drawing an altitude, this forms a right angle. What statement is always true? So with these kinds of questions, we're always dealing with 3 triangles and they're all similar to each other by angle. That's why they end up having all these proportions. So let's draw out each of these triangles separately and make sure that they're in the right order so they're easy to compare. So first let me draw out the big triangle, the biggest one, this triangle RST. And notice I'm gonna have the right angles in the bottom left corner, and then we have the hypotenuse, and then the longest leg and the shortest leg is the base. So I'm gonna keep that pattern going when I draw out all of these triangles. So the next medium-sized triangle will be this triangle SVT. So notice the right angle is over here. And in this case, we're gonna like flip this triangle a little bit so it's in the right order. So the V is the right angle, and then notice the shorter side is to S and the longer side is to T. And lastly, we're gonna draw the small triangle RSV. You can see that the right angle is at V again, and then the shorter side is to R and the longer side is to S. So now let's look at each of these answer choices and see which one makes sense. So RT, so RT is over here to ST over here, so we have hypotenuse to hypotenuse is equal to ST, this long leg, to VT, this long leg. So this looks right to me because we're dealing with exclusively these two triangles and each side length matches up. So RT, this hypotenuse to this hypotenuse, ST, is congruent to ST, this long leg, compared to this long leg, BT. So this to me looks like it's going to be the right answer. So I'm just going to circle it, and let's go through the other answer choices to make sure that this is right. So if we look at VR is over here, this is the base of the smaller triangle, to VT. So now notice we're going from the base of this smaller triangle to the long leg of the other, a different triangle. So that's not correct. We're looking at RV to SV. RV to SV. Okay, so that's one base to another base. Okay, and then SV again. So RV to SV, and then SV, this longer side, to RT. So RT is now on a different triangle. So at first it looked good, RV to SV, base to base, and then so at first this looked good, but then it says SV to RT, which is this long leg to this completely different triangle's hypotenuse. So that's not our answer. And then the last one, it says TR over here, this hypotenuse over VR. So we have the hypotenuse of the big triangle and then the base of the small triangle. So that's not our answer either. So the answer here, the only one that makes sense, is choice number 1. Question 20. What is the measure in radians of a central angle that intercepts an arc length of 12 pi centimeters in a circle with a diameter of 36 centimeters? So let me sketch this out. So we have a circle, and then it says we want to know the measure in radians of a central angle. So a central angle that intercepts an arc length of 12 pi in a circle with a diameter of 36 centimeters. So we're looking for this angle right here, the central angle. We'll say that's the center. And then this entire diameter has a length of 36 centimeters. So here we're going to be using a special formula, the central angle formula. This is S equals R times theta, where S is the arc length, which they said is 12 pi. R is the radius, and then theta is that central angle that we're trying to find. So in this case, we have everything we need to find the central angle. So we have the arc length, which is 12 pi. The radius, so they give us the diameter, which is 36, so the radius is just going to be equal to 18 centimeters. So we have 12 pi equals 18, and then that central angle is theta. So now we just need to solve for theta. So to do that, we're just going to divide 18 on both sides, and we get 12 pi over 18 is equal to theta. But when you look at the answer choices, you could see that's not exactly there. So we can reduce this a bit. 12 divided by 18. This can be reduced to 2 pi over 3, which is choice number 3. Question 21. A regular nonagon has a center point P. What degree of rotation about point P will carry the nonagon onto itself? So a nonagon is a polygon with 9 sides. And since it's regular, that means each of these angles are going to be equal. So it's a little hard to draw. It's a lot of sides. And the center is at point P. So if we have 9 sides, we're saying how many rotations about point P will put it onto itself. So we rotated this image. What would it take for it to go onto itself? So if we take 360 degrees and divide it by 9 for 9 sides, we get 40 degrees. So that means any number we see here in the answer choices that is a multiple of 40 degrees is going to turn the shape onto itself. So the way to do that, if one of these numbers is a multiple of 40 degrees, is just to divide each number by 40 degrees. So you can see choices 1 and 2 are not multiples of 40 degrees, right? 60 is not going to be multiple. And 90 is not a multiple, right? Because 40 plus 40 is 80, so 90 is not a multiple. And if you divided these, you would quickly see that, right? This leads to a decimal, 2.25, so that's not our answer. So now let's look at number 3, 180 divided by 40, 4.5. So no, that's not it. And now it has to be choice number 4, but let's see. 200 divided by 40, so this is going to be 5. So 200 over 40 equals 5. And what this 5 represents, this is our answer. This 5 represents 5 rotations. 200 degrees would give us 5 rotations of our nonagon, which it would rotate onto itself. So that's why choice number 4 is our answer. Question 22. If two sides of a triangle have lengths of 2 and 7, the length of the third side could be what? So what this is asking is, this is talking about the triangle inequality theorem. So this states that the sum of any two sides of a triangle must be greater than the third side. In other words, A plus B must be greater than C. And this works for all the sides, so this would also be like A plus C is greater than B, and C plus B is greater than A. So all of these must be true. So when we look at these numbers, you could see that already we can eliminate choice 1. 7 plus 2 would not be greater than 9. 7 plus 2 is 9, right? So 7 plus 2 is greater than all these other numbers, but what about if we chose these other numbers? So for example, if we chose 4, that would mean 4 plus 2 would have to be greater than 7, which it isn't. 4 plus 2 is 6, which is not greater than 7. And the same can be said about 5. 5 plus 2 is 7, which is not greater than 7, so that's not our answer. So the choice here is choice number 2 with 8, because 7 plus 2 is 9. So let me just write out all the reasons. 7 plus 2 is 9, which is greater than 8. Right, and then we have to think about all the other ways this also works. So 2 plus 8 is 10, which is greater than 7. So that works out, right? And then the last way is 8 plus 7 is also greater than 2. So choice 2 is our answer. These all have to work out when we're dealing with the lengths of a triangle. The sum of any two sides must be greater than that third side. Question 23. The car tire shown in the photograph below has a diameter of 2 1/4 feet. So let me just draw that out over on here on the side. So 2 1/4, or 2.25. Approximately how many rotations will the tire make in 1 mile? One thing we want to know is how many feet are in a mile. So 1 mile is equal to 5,280 feet. But that's not going to give us our answer alone, right? What we need to think about is how big this tire is, and what the circumference of the tire is, and how many rotations that's going to take. So what is our circumference? It's always equal to pi times diameter. So pi times the diameter, 2.25. To answer the question, how many rotations will it take, we're going to take the number of feet that are in 1 mile and divide it by the circumference. When we do that, we'll get about 747 rotations. Choice number 2. Question 24. In quadrilateral TOWN, OW is congruent to TN and OT is congruent to WN. Which additional information is sufficient to prove quadrilateral town is a rhombus? So the first thing I'm going to want to do here is just sketch out our quadrilateral. So we're trying to prove this is a rhombus. So I'm going to draw a rhombus. And to label this, I'm going to start over here and then just go clockwise. So TOWN, and then it says OW is congruent to TN and OT is congruent to WN. So now it's asking us what other information is sufficient to prove this is a rhombus. So to prove something is a rhombus, it has all the properties of a parallelogram, but then it has additional properties that are special to being a rhombus. And that's what we're going to be looking for in this answer here. So let's write out the properties of a rhombus. So the first thing we have is the diagonals of a rhombus bisect each angle. Another property of a rhombus is that the diagonals are perpendicular. And the third property that's specific to only rhombuses is that all four sides of a rhombus are congruent. So that's what we're going to be looking for when we look through these answer choices. So let's go through each one. So the first one says ON is perpendicular to TW. ON is perpendicular to TW. So actually this is going to be our answer because this aligns with the diagonals being perpendicular, right? These are the diagonals. ON this way is perpendicular to TW. So choice 1 is our answer, but let's go through the others and see why. So TO is perpendicular to OW. These are consecutive sides, so this would be more for a rectangle or a square, not for a rhombus. Our next one, OW is parallel to TN. So that should be true for a rhombus, but it's also true for all parallelograms. So this is too general and does not specify for a rhombus only. So this would be for all parallelograms. So that's why this is not our answer. And then the last choice, ON and TW bisect each other. So again, that's true for a rhombus, but it's true for all parallelograms as well. That's not what we're looking for here. So the only answer choice that makes sense here is choice number 1, which is our answer. So that's the end of part 1. Look out for part 2 coming out soon. Please let me know if you have any questions. Good luck and happy calculating!